So we are adopting a sequence which may not be as per the exact content, but which is such that it should be very easy for you to understand. So again, means the crux of this subject is interconnection between R, L and C, and then amplifier and adder in case of active circuits subjected to various voltage sources and current sources. Actually, current source we have not discussed. I have not uploaded also. You are supposed to go through all uploaded lectures. I would like that the collective time of all of us should be spent in more meaningful discussion rather than simple discussion. जे सोपं आहे त्यात वेळ जायला नको म्हणून ते बघायचे सगळ्यांनी. So all should now look at the whiteboard. Here again differential equation is required to be prepared. So preparing differential equation and finding its solution is a straightforward approach, but finding solution not so easy, so we have different methods. So in one case we assume that e raised to something is there, in some case we assume that cos omega t, a cos omega t, b cos omega t plus a sin omega t is the solution. Last time what we did, if you have gone through my lectures on complex exponential, then you might have got a more appropriate view. Even otherwise also, what we have discussed, that sinusoidal is a typical type wherein no need to discuss. सोडवायचं नाही आता आधी बघायचं मग सोडवायचं. Listen very carefully, everybody should look at the whiteboard. So for sinusoidal waveform, differential operator becomes a scaling operator. Is it clear? This must be very well noted by everybody. Differential operator becomes a scaling operator. Therefore, now I am sure that in basic electrical engineering last year, also maybe in 12th, for resistor you have concept of resistance, right? What is resistance? Voltage across it upon current through it. But for capacitor or for inductor, such concept is not there. What is the reason for resistance to be straightway clear? Because for resistor, V is voltage across it is equal to resistance into current through it. So there is a direct linear relationship between V and I. So V upon I is R. But for capacitor, such a relationship is not there. For inductor, such relationship is not there. What is the relationship for capacitor? IT is equal to C dVt by dt, or I can say ICT, VCT, here IRT, VRT, right? So you can't write the ratio of V upon I directly there. But under a special case of sinusoidal signals, d by dt operator, sinusoidal signal means what? Voltage is of the type something cos omega t plus phi, or b sin omega t plus b cos omega t plus a sin omega t. Is it right? What is a sinusoidal signal? A sinusoidal signal is represented by the form a sin omega t plus phi, or b cos omega t plus a sin omega t, either way. So whenever it is of the type, when in case of a sinusoidal signal, a sin omega t plus phi, that doesn't matter because in derivative that phi doesn't come directly. So its derivative, its d by dt of a sinusoid is a omega cos omega t plus phi. Means what is important is differential of a sinusoid is always a sinusoid of same frequency, of different amplitude, amplitude different, and its sign is cos. So this cos can also be written as sine of something. Cos can be written as sine of omega t plus something. It is pi plus pi or minus pi by 2 as you can interrelate. So different phase, right? So sine and cos, you can look at the phase. Is it right? Differential of a sinusoid is sinusoid of same frequency of different amplitude, different phase. Likewise the integral. Now there is a shortcut which you may realize later why it is to be used. So what is the shortcut I told? That sine to cos transition is a phase transition. Sine to cos transition is a phase transition. Agreed? Then we go in complex number theory, you know that angle 0, angle pi by 2, angle pi and angle 3 pi by 2 and 2 pi becoming 0. 2 pi becoming 0. Is it right? Is it okay? So, and here you are here 1 j minus 1 minus j. So there is some, means I am just trying to give you some kind of connect so that you should not find it something absurd or non-correlative. So sine to cos is 90 degrees phase shift. That 90 degrees is represented by j. So j is an alternative method of representing phase shift. So remember this thing only, cos, cos equal to j sine. Cos equal to j sine. जे असलेले नंबर आणि जे नसलेले नंबर एकत्र मिळवायचे नाहीत आणि शेवटी जे स्क्वेअर इक्वल टू -1 वापरायचं आणि शेवटच्या अगदी शेवटच्या मध्ये जे ठेवायचा नाही. इमॅजिनरी. If we do this, is it right? Simple thumb rules. J square equal to -1. J sine is cos. Multiplying both sides by j. J square sine is j cos. J square -1. So minus j cos is minus sine. Right? Only two things. J cos equal to j sine. J square equal to -1. J terms are not to be mixed with non-j terms. There is no j term in the beginning. There is no j term in the end. Right? No, j is imaginary. It is not there. Initially it's not there. Finally it's not there. In between we use it. J sine equal to cos. J square equal to -1. J terms are not to be mixed with non-j terms. They are to be kept separately. That's all. So with this now, this is the capacitor. Now if I am applying, I am sure that the voltage which I am going to apply for the capacitor of sinusoid, then what would be the current? If voltage is sinusoid, a sinusoid is what? A sine omega t plus phi is voltage, right? VCT. What is ICT? ICT is equal to omega A omega right? Is it okay? Agreed? Into C. It is capacity. So C dVc by dt, right? It is VCT. It is ICT. So ICT is, VCT is this, ICT is C into, is it right? Is it okay? Then what is, if I consider C to be like resistance, what can I do? VCT by ICT? Can I take the ratio of VCT by ICT? And if that, what is the ratio there? It is what it is? 1 upon omega c tan omega t. असं कुठे ऐकलं तुम्ही? Have you heard anywhere that resistance like parameter for capacitor is called as impedance? Resistance like parameter for capacitor is impedance is 1 upon omega c tan omega t. ऐकलं कुठं? काय ऐकलं नाही? Actually, if ratio is to be taken, for resistor always there will be constant ratio, whereas for capacitor instantaneous ratio is different. Tan means what will happen? It would be sometimes voltage is there, no current. Sometimes current is there but no instantaneous voltage. If you plot voltage signal and current signal at instant by instant, you find that the ratios will be different. So there is no point in putting tan. So here you use this simple technique that cos equal to j sine. So directly what you have heard, xc equal to 1 upon j omega c, right? Because cos becomes j sine omega t plus phi, and then obviously this gets cancelled, this gets cancelled, sine gets cancelled. What remains is a gets cancelled, 1 upon j omega c, right? So this is called as xc, that is resistance like parameter for capacitor. Resistance like parameter for capacitor, xc is equal to 1 upon j omega c. हे तुम्ही कधी शिकलाय? When you have come to know about it? 12th? But have you understood what is the significance of imaginary impedance? Imaginary impedance you could not understand. So what that indicates, that J indicates that, so that has got two parts. One is J and other is 1 upon omega c. So I can multiply numerator and denominator by J. So it becomes what? X is equal to minus J into, right? So 1 upon omega c is the ratio of voltage upon current. Voltage across capacitor upon current through capacitor, the ratio is 1 upon omega c. And what that J indicates, अरे बोलनो का था इकडे बघा, what J indicates? J indicates that, can anybody complete? Remember, the concept of impedance of a capacitor is applicable only for sinusoidal waveforms. Resistor has no such restriction. Even for DC it is same, for AC it is same. Whereas for capacitor, when I connect a DC source, I talk in terms of charging, discharging, and when I connect AC source, I talk in terms of impedance. Why? Because the relationship of differential to be a multiplier in terms of J is applicable only in case of sinusoidal input. In case of non-sinusoidal input, we cannot establish a relationship between voltage and current so easily. लक्षात आलं का? For sinusoidal signal which is there, that is AC mains majoritarily, and other AC circuits also in audio and all these things, the conserved impedance is there. So by using J, we can very easily compute. What will be the voltage across any 2 points, current through any branch. बोलायची काय गरज नाही. हे सगळं येत असेल तर हे खूप सोपं वाटतं, तर मी लगेच एक्झाम्पल देणार आहे. मग असं तर आहे, त्यापेक्षा सोपं देणार आहे, ते येत नाही तुम्हाला दाखवणार आहे, म्हणजे तुम्हाला मी जे काय सांगतो सिग्निफिकन्स कळेल. Again we start with this. It is our very big, and ते मध्ये टास्क देतात तुम्हाला, आठवलं काय? 2 वेळेस ते आले का उत्तर? आलं नाही? कुठला ते टास्क दिला आपल्याला? एक टास्क दिलाय. कुठला? 2 रेजिस्टर 2 कॅपॅसिटर नंतर याच्यावर टाकतो. आता त्याचं उदाहरण. आणि पुन्हा सोपं, अगदी सोपं. यासारखं सोपं सर्किट आपण पुन्हा घेत नाही पुन्हा. आता पुन्हा घेता काय घेऊया? सोपं घेऊया. 1च घेऊया आता. 1 sin ओमेगा टी. आता पूर्वी डिफरन्शियल इक्वेशन, आता पूर्वी डिफरन्शियल इक्वेशन घेऊन काढलं, आता डिफरन्शियल इक्वेशनची गरज नाही. का गरज नाही? आता पण तुम्ही डिफरन्शियल इक्वेशन करायला लागला, इट विल बी ऑल वेस्ट ऑफ दिस डिस्कशन. का गरज नाही? नाही, डिफरन्शियलची का गरज नाही? डिफरन्शियल म्हणजे काय? डी बाय डी टी इज इक्वल टू, आता काय द्या तुम्ही, डी बाय डी टी इज जे ओमेगा. का? डी बाय डी टी ऑफ साइन काय? हे अगदी एकदम सोपं, म्हणजे तुम्ही शाळेत एक महिन्यात असता, आता उद्या परीक्षा काही अभ्यास झालेला नाही तर कसं काय ते टेक्निक सांगतात तसं, पण लॉजिक आहे त्याला. डी बाय डी टी ऑफ साइन ओमेगा टी काय तो? ओमेगा कॉस ओमेगा टी. पण कॉस म्हणजे काय? जे साइन. बरोबर? म्हणजे काय? जे ओमेगा साइन ओमेगा टी. म्हणजे डी बाय डी टी इज जे means in a sinusoidal signal application, आता differential equation काय येणार नाही? Why differential equation will not be there at all? What is the reason? What is the reason? The differential operator becomes a scaling operator of j omega. d by dt च्या ठिकाणी j omega येणार, right? d by dt च्या j omega येणार, किंवा तिथपर्यंत पण जायची गरज नाही. लुक, कॅपॅसिटर आणखी सोपं, ट्रीट कॅपॅसिटर लाईक ए रेझिस्टर. डिफरन्शियल इक्वेशन घेऊ शकतो पाहिजे तर, पुन्हा त्याही प्रकार आय विल शो यू बोथ वेज. डिफरन्शियल इक्वेशन काय यायचं माहिती आहे आपल्याला? d VOT by dt plus VOT is equal to V, right? Is it okay? What is d VOT by dt? d by dt is j omega, right? So j omega VOT, हे वन पॉइंट आहे इक्वेशन. सी असलं वेगळं असलं, दिस इज इक्वेशन फॉर सी इक्वल टू 1 आर इक्वल टू 1. ते करता मग घेऊया, म्हणजे 1 अपॉन जे ओमेगा सी काय येत नाही. तर जे ओमेगा व्हीओटी प्लस व्हीओटी इज इक्वल टू व्ही इन टी. म्हणजे आता काय झालं? सो व्हीओटी इज इक्वल टू व्ही इन टी अपॉन 1 प्लस जे ओमेगा. दॅट्स ऑल. आणखी पुढचे वन मोर टेक्निक, जे cos इक्वल टू जे साइन, जे स्क्वेअर इक्वल टू -1, no terms of j initially, no terms of j finally, j terms are to be separated with non j not to be mixed, and no j term in the denominator. No j term in the denominator means what? Rationalize, right? No j term into denominator, so multiply by 1 minus j omega, so it becomes 1 minus j omega v in t upon 1 plus, right? Is it okay? 1 plus omega square. What is v in t? What is v in t? 1 minus j omega sin omega t upon 1 plus omega square. Fine line. But in fine lines, this is not a fine line. So why? J should not be kept. It's easy. Means one may say in a wrong manner, use and throw policy. So introduce J, so to simplify the things, but don't keep J at the end. Now, so what is VOT? VOT is equal to 1 minus j omega sin omega t upon 1 plus omega square, right? What that is? Sin omega t minus j omega sin omega t upon what is j sin is cos. J sin is cos. So sin omega t minus omega cos omega t upon 1 plus omega square is finalized. right? So final answer will be in terms of something sine plus something cos. To be very precise, we write 1 upon 1 plus omega square sin omega t minus omega upon 1 plus omega square or plus into bracket minus omega, either way. And then this you can reduce into form. Calculate. Something wrong? So this ultimately something sine plus something cos is always some other thing sine omega t plus phi. लक्षात लगा, something sine omega t plus something cos omega t is always some other thing sine of omega t plus phi. What is that some other thing? The square root of these two. And what is that phi? Tan inverse of ratio. For ratio you should be, for amplitude it is very clear, for ratio you should be very specific which term and which term. Is it clear? With this now you must be able to solve the initial problem. What was the problem we started? So with this now, everybody should solve a very simple problem. I am explaining the thing in such a manner that आत्तापर्यंत काही कळलं नसतं ते यायला पाहिजे. Compute cos omega t. We take a break for recording.